So, the first part of the question asks us to prove that always the probability of x given y multiplied by f of y summed over all possible values of x will be equal to f of y. Okay, so the general way we try and do a proof is to show that the left-hand side is equivalent to the right-hand side. And usually it's easier to start with the more complicated side, and in this case that is the left-hand side. So as the first step, what we can do is remove the f of y from the summation to put it outside, because that makes it a bit easier to understand what the summation is over. Now that we've done that, we can exploit the idea of conditional probability. Here we've literally used a definition that probability of x given y is the probability of x and y divided by the probability of y, the marginal. Okay, so now that we have it in this form, we can once again remove the terms which do not contain x, which is probability of y. And now inside the summation we only have one term, probability of x and y. But studying this term in detail, we can quickly notice that we can exploit the rule of marginalisation, because by definition, summing over all possible values of x for probability of x and y will give you probability of y. Oh hey, now we can just cancel out the terms probability of y from the numerator and denominator, and we do end up with our right-hand side. So that was the first part of the question. Let's now move on to the second half. So the second half asks us to prove that in general, the probability of x given y multiplied by the f of x and y summed over all values of x is not just equal to f of x and y summed over all values of x. So the main point to notice here is that the slight difference is that the function is now a function of x and y and not of just y. So the main point here is that it should be kind of obvious if you work through the first question, that we cannot remove f of x and y from the summation now, because it does contain the term x. And more importantly, the two terms, the probability of x given y and f of x and y, are tied together. We cannot separate these two identities. I can't have two separate summations, which means it's impossible in general to show that this will simplify to the sum of f of x and y over all values of x. But to pinpoint exactly what rule we are using, we can say we are using this general rule, that if we have two functions of the same variable, and we are summing over that variable, and these two functions are being multiplied together, we cannot separate the two multiplied parts. So I can't say f1 of a multiplied by f2 of a summed over all values of a is equal to f1 of a summed over all values of a multiplied by f2 of a summed over all values of a. If you don't believe this, you can quickly try and substitute some example functions to check for yourself that this will not be true in general, though it may be true for some certain functions. But let's quickly work through an example for our original question to disprove that the expression given will be true. So in our example, let's let x and y be binary variables which can only hold the values of 0 and 1. And the probability of x equals 0 or the probability of x equal 1, regardless of the value of y, will be equal to a half. Let's let our function be x squared y. Now, when we substitute into our top expression, so the show in general part of the top right hand side of the screen, we find our left hand side will be equal to half y, and our right hand side is equal to y. So yes, as we have shown, that for this specific case, the left hand side is not equal to right hand side. And using the above argument I gave earlier, it is justified to say that the statement is not true in general, though it can be true for certain functions.